welcome back to Decaf-Math. If you are new here, welcome, welcome. It's awesome to have you. So, ta-da, 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 this is my new little setup here. I thought that we could try doing some math on a whiteboard, and if all goes well and I don't knock everything over, I imagine that this little setup will be something that I use again in the future, in some of my future videos. So definitely let me know whether or not you like it. But I made a little math nook here, so I'm excited to give it a try. So I thought we could test out the whiteboard by continuing a topic that we've kind of already started. We kind of did double angle equations, but we really just focused on memorizing. So that was a sleepy math memorize study with me type video, but we haven't worked through specific problems. And if you do want to work through practice problems, let me know. But otherwise I'll just kind of continue filling in the gaps. I kind of jumped from intro to trig, didn't even do basic angles, jumped into double angles, and today we're going to do half angles. So I just wanted to touch on this because our awesome viewer requested it, and I wanted to make sure that they were on their way. So I wrote the equations here already, but instead of memorizing them together today, I thought that we could work through an example, maybe two if we get around to it, for how to apply these equations. So and then I thought that maybe seeing an example worked out for half angles, you could extrapolate for double angles as well, and at least it could get you started as I kind of jump around and fill in with more practice. But if you want to see more sooner rather than later, definitely don't hesitate to let me know. So let's just kind of go over the equations, but just take your time to memorize them. Again, this is not a memorize with me video, but maybe if you're just kind of staring at them all throughout this video, you'll have them memorized. But if you're not taking trig or anything and this is way over your head, just relax, relax. And if you are in trig, of course, relax, relax. But if you need to know this stuff, don't fall asleep. Nope. But either way, it's Decaf-Math, so just chill. So sine of theta over 2 equals plus or minus the square root of 1 minus cosine theta all over 2. Okay, cosine theta over 2 equals plus or minus the square root of 1 plus cosine theta all over 2. Tangent theta over 2 equals sine theta over 1 plus cosine theta. So these are our three equations. Okay, I circled theta over 2 because I wanted to emphasize that we're talking about theta over 2, half angle, so sine of that. If you want to make it clear, you can put parentheses here, whatever you prefer. But we're talking about sine theta over 2. So we memorized sine 2a. We memorized that's 2 sine A, cosine A. But here we have sine theta over 2. So this is what we mean by half angle. Okay? So just little things to point out. The only difference between sine and cosine for here is the minus and the plus. Okay? Sine has a minus, cosine has a plus. I also wrote this in terms of theta this time, so we can use A, we can use alpha, we can use X, Y, beta, whatever you want for the angles, as long as you are clear with what they mean. So especially if you use X and Y, be clear that that's not our normal xy coordinates on the coordinate plane, the Cartesian coordinate plane. Just be clear that that just stands for our angles. So as long as we know we're working with angles and we are consistent, you can use whatever you want, whatever symbol. You know, my favorite is to throw in a little heart there. So whatever symbol, but this little loop-de-loop thing, the loop, 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 that is theta. So, let's see, what else is there? Okay, this little thing, this thing is plus or minus, and you pick which one based on the problem. And to look ahead a little bit, it really depends on which quadrant theta over 2 is in, because that will determine the sign, the plus or minus sign. This is going to get confusing, but the sign of plus or minus, not the trig function sign, but that will determine the sign whether you pick the plus or the minus answer. So you will just pick one of these and you'll pick that accordingly. Okay, so let's see. So other notes here, there is another form for this tangent one where sine theta is in the denominator, but it's an equivalent form, kind of like when we had cosine of 2a. We had 3 equivalent forms, but they all are variations of the same thing. If you combine the fact that cosine squared plus sine squared equals 1, and you do a little bit of algebra here. For example, you multiply by 1 minus cosine theta on the top and the bottom, find conjugate pairs, find difference of squares, etc., etc. It algebraically works out to be like, I think it's 1 minus cosine theta or something over sine theta, but I am a proponent of memorizing the fewest number of things possible, so this one is good, and I think it's just kind of easier to memorize. That's just my opinion though, so whatever works for you. But remember, tangent is always sine over cosine anyway. Okay, so let's do an example of using these equations. Let us do sine of 15 degrees. Okay, sine of 15 degrees. So what you do is set your 15 degrees to equal your theta over 2. Okay, so we're going to set this thing to equal theta over 2, because we have an equation that will relate sine of this theta over 2 to this cosine of theta. So we need to solve for what theta is. But if theta over 2 equals 15 degrees, then theta equals, you can multiply by 2, right? Multiply 15 by 2, so 30 degrees. Okay, so 30 degrees divided by 2 is 15 degrees, so we're good to go. So theta equals 30 degrees. So here we just plug and chug. So 15 degrees is our theta over 2. We find what theta is by just multiplying that by 2. We plug into our equation and we get plus or minus the square root of 1 minus cosine 30, because theta is 30 all over 2. See that? Okay, so we find what theta is and then we just plug it in. So what's so special about this? Well, 30 degrees is one of our special angles. I assume that if you are learning half angle formulas that you've already learned your unit circle special angles. So I'm talking about 0, 30 degrees, 45 degrees, 60 degrees, 90 degrees, and all of their counterparts in quadrants 2, 3, and 4. If none of that made sense to you, let me know, and I will be making the rest of the special angle videos. I'm gonna fill in the gaps between intro to trig to now soon, so, and you know it's gonna be pretty and colorful too. But let me know if you want to see that sooner rather than later as well. But 30 degrees is one of them, and that means that we know precisely what cosine 30 degrees is. Might need to review a little bit, but we have an exact value. That value is, well, sine 30 is 1/2. Cosine 30 degrees is the square root of 3 over 2. Again, if you didn't know that, this isn't making sense, consider it math magic. But indeed, we have an exact value for it, so I'm just going to write that, the square root of 3 over 2. Okay, so then we can do a little bit of simplifying here if we want to, though it's not totally necessary. So either at this point you can find a common denominator for the numerator, and then that was confusing, but common denominator for the numerator, divide by 2 also, so bring it all in the same layer, or you can just multiply the top by 2 and the bottom by 2. So you get, either way, you get 2 minus root 3 all over 4, I believe. And if you want, you can pull that root 4 out of the bottom if you actually care. But I'm just going to leave it like this, and that is our answer. I know it's not totally satisfying to have a square root within a square root, but oh well, at least it gives us an exact value. That's the cool thing. So if you plug in 15 degrees or sine 15 degrees, I mean, in your calculator you'll probably get a decimal, but this gives us an exact value. From here you can approximate it too, just to make sure you got the right answer, but this is because 15 degrees is half of 30 degrees, and 30 degrees is our special angle. Now the question is, do we pick plus or minus? Do we pick plus or minus here and here? Okay, so I'm just gonna just circle this here, because I don't want, as you're going back, if you're reviewing this, I don't want that to get confusing, but we kind of leave the plus or minus, then we can go back and decide which one to pick. So what we need to do for that is to figure out which quadrant 15 degrees is in. So what I mean is, we'll just kind of sketch a small unit circle here just to give a picture. But again, if you need to review this, let me know. But we have our unit circle. We start at 0 for our angle, and then we move counterclockwise all the way around to 360 degrees, right? So 0 to 90, 180, 270, all the way back to 360. So the quadrants go like this. This is 1, 2, 3 quadrants, meaning 4 of them, right? 4. And what's special about them is that our angle will be associated with a point on the unit circle. So if we have a point here, for example, I would draw the segment from the center to that point. Okay, it's a little segment. So my 0, 0 is my origin. That's the center of my unit circle. I draw that, and that marks out that angle here with the positive x direction. This part here with that marks out an angle, and I'm going to call that alpha, like that. Okay, so it can be like here, and then the alpha would be like this whole thing, but either way it marks out an angle. That's the angle that, and I'm calling that alpha because I don't want to confuse, if I wrote that as theta, I don't want to confuse that with this theta or theta over 2 and all that. So basically that angle, whatever name you want to call it. Okay, so the important thing about this though is that each point on the unit circle has the Cartesian coordinates x comma y, but with a little bit of SOHCAHTOA on our unit circle. If you want to see this written out, you can check out the Intro to Trig video. But basically, cosine alpha is x, cosine is x, sine alpha is y, cosine is x, sine is y on this unit circle. Okay, so what we do is we find the angle that we're our theta over 2, right? 15 degrees is our theta over 2. Since we're looking for sine of 15 degrees, I want to know if that is positive or negative. So I need to find 15 degrees. I see that from 15 degrees is in quadrant 1 because it's between 0 and 90 degrees. So 15 degrees. And what I noticed there is that the x coordinates in quadrant 1 are positive and the y coordinates are positive. You're going to the right and up, right? So positive, positive, which means cosine of any angle in quadrant 1 is positive and sine of that angle is positive. So sine would be positive for sine 15. So we just take the plus, which means that we don't need to worry about this minus anymore. So we don't need to worry about the minus anymore, and we don't even need to put in a plus because, we don't write plus 5 like that. We can just leave it as 5. So we just erase it, and that's our final answer. So we can just get rid of this and get rid of this, and that is our final answer. So to elaborate on this part a little bit, basically if we have, for example, a point in quadrant 2, so if we have an angle between 90 degrees and 180 degrees, my x coordinate is negative, so cosine is negative. My y coordinate would be positive, so sine would be positive. So you just need to look at which trig function you're looking at and which one you're trying to find, and then you need to find which quadrant my theta over 2 is in and match up if my x or y is positive or negative. That's it. So I hope that helps. It definitely will help to be familiar with your quadrants and how working with the unit circle works. And like I said, I will go back and fill in those. But for now, the key thing is set your theta over 2 to be your angle. Whether or not that's in degrees or radians, it works exactly the same. Just remember, in radians, you're going from 0 to 2 pi. In degrees, you're going from 0 to 360, and if you happen to get anything bigger than that, just remember that it's cyclical, so every time you have 360, you're just basically resetting back to 0. Then you set theta over 2 to equal that, and then you can multiply your angle by 2 to get your actual theta. Ideally, it'll be and that's usually the reason we even use these equations in the first place. Ideally, that angle, after you multiply by 2, your theta is a special angle or something that you could otherwise get an exact value for. Then you plug and chug into your corresponding formula, whether you're finding sine, cosine, or tangent. And then if you're doing sine and cosine, you go ahead and determine which quadrant your theta over 2 is in. Then you determine from whether or not x and y are positive or negative. You find the sign, whether it's plus or minus. So remember, x is cosine and y is sine, okay? And that's it. It's as simple as that. For tangent, you just go ahead and plug and chug, and that's it. You don't need to worry about the plus or minus there. If you want a little challenge question, you can try finding the cosine. Let's see here. Try finding the cosine of 3 pi over 4. So this is in radians. This isn't a test or anything, but just in case you wanted to give it a go. So this is in radians now. And so we're going to be using this equation, so this formula, and remember, we're going to just go ahead and set this to equal theta over 2, so figure out what theta equals, plug and chug. Remember that cosine of that angle, just a hint, it is a special angle, and I'll let you take it from there, but you will get plus or minus the square root of 2 over 2 after you rationalize stuff, and that's as much of a hint as I'll give you. Then you need to determine if it's plus or minus, and 3 pi over 4, I will give you this hint, it's in quadrant 2. So you let me know what you get, comment it down below, and don't hesitate to let me know if you have any questions on half angles or anything else. Thanks so much for joining me today. I hope that you are relaxing or are relaxed. And if it's nighttime for you, just close your eyes, close your eyes, close your eyes. Or maybe you had a little mini nap. And if you are learning this stuff, I hope that this clarified everything you could ever need to know. I will see you next time. Bye.